What's going on? What's going on? What is going on? Just trying to make sure everything is set up for this presentation. We got a great presentation today. I'm gonna make sure everything is set up for y'all, for the universe out there. All right. So this is a Trade Digital channel. My name is Deshaun Lyons. I'll be doing a presentation on data science. We'll be doing a presentation. It's beginner friendly. It's not going to be anything that's too hard to understand and not really interesting. We're going to do a lot of things when it comes to data analytics, Numpy arrays, looking at knowing the difference between rows and columns, and things of that nature. Excuse me. Just different ways to manipulate data and also see the visual, how it comes to life, what we implement on Matplotlib. So we can begin this presentation right now. So let me share my screen. And we're going to start with our script here. So let me make sure we up and running. Okay, let's make sure we're up and running. I gotta look on my end and everything is correct. I heard something though. Let me see. All right, so let's get to the coding part. So the first thing we're going to do, let me turn this off. All right, the first thing we're going to do is import Numpy as MP. And we have to figure out what is Numpy and what is the use cases for that. So let's go to my presentation. I use this PowerPoint for the students I teach in Uganda. And we went over a lot of things that I'll be going over today. So I would have to just do it like this for now. So Numpy arrays. Numpy is the core library for scientific computing in Python. A Numpy array is a grid of values, all of the same type, and is indexed by a tuple of non-negative integers. The number of the dimensions is the rank of the array. The shape of an array is a tuple of integers giving the size of the array along each dimension. So if you look at this example we have right here with these pictures, you see it says on NumPy and it says end array. So you got a one-dimensional array here. So a one-dimensional array is just you just see one row and then you'll see columns 1, 2, 3, 4, 5. So you'll see five columns here. So this is so it would be 5 values in here: 10, 15, 13, 8, and 25. So this would be a one-dimensional array. Just only have one row. So, and then they show the description with two-dimensional array right here. But remember, Python counts zero as a number, which so you'll see 3 rows here, but it'll be a two-dimensional array. So this would be, it will be a number. It'll be 10, 15, 13, 8, 25. Then there'll be another number down to make a two-dimensional array. And then you'll see a three-dimensional array right here. 1, 2, 3, 3 rows. And then you see I have 3 columns. So you see the first dimension right here, the second dimension right there, and then the third dimension right there. So that's a 3-dimensional array. So now let's code it so we can figure it out. So the first thing we'll do is we'll make ARR. But we'll do x equal to np dot array, and then let's make a one-dimensional array. So we'll do 1, 2, 3, 4, 5, 6, 7, 8. So when we print this out, when we print the variable that we initiate this array to be, which is x, and rerun this, and you'll see we get this as our array right here. So this would be considered a one-dimensional array. This would be considered one-dimensional. Let me copy this so we can know what it is right here. So the output for this code would be a one-dimensional array. Let me put it right here. So it'll be 1D array. So if we want to do a two-dimensional array, so we can make x1 to equal to np dot array, and then we can make a two-dimensional array. So we got to add two brackets to it. So we'll add 1 or 2, 4, 6, 8. We'll add 8, and then we'll add another column here. It could be 10, 12, 14, 16. So now we have two brackets added to here. So when we print this, x1, and we run this one, you see in the bottom here, we get a two-dimensional array. So you see it's two rows right here. So it's two-dimensional. We have one row right here, and these is two rows. And then but it's 4 columns long. So there's also a function to validate if that's a two-dimensional array too, and it's called the shape function. So the shape function is we're going to find out the actual size of this array. So what we'll do is we'll put print. Let me put inside a string ... so I can separate it. Let me put ... right here so we can separate. So we'll put print x dot shape. So we'll find the shape of this one of x, which is this one-dimensional array. So we run that. You see the shape is 8. So only got one value because it's a one-dimensional array. So the shape 8 right there. So we do the same thing for this. Let me put this in the bottom too, so we can make sure everything is separated. So we do the same thing for that, and we print x1 dot shape to find the shape of this array. And we run that. You see it's 2 by 4. So remember, it's only a one-dimensional array, so it's just going to give us the columns. So it's going to be 8 columns. Now, this is a two-dimensional array. It's going to say it's 2 rows and it's 4 columns long of each row. So this is considered a two-dimensional array. So that's another thing we can do. We can do the same thing for a three-dimensional. So let's do one for y. Y equals y, or we just keep it x. X2 equals np dot array, and we'll create a three-dimensional one. So we got 3 brackets added to it. So we'll put, let's do 2 numbers. 2, another bracket, 3, 4, put another bracket. Oh, gotta make sure we put a comma there. Put a comma there as well. And then we'll make it 5 and 6. So even though we have 2 values in each column, it'll be still considered a three-dimensional array when we print it out. So let's print this out, x2. And you see right here, we'll get a three-dimensional array here. So this is three-dimensional, but it's only 2 columns long. So now when we find the shape for that, if we find the shape of this particular array, this three-dimensional array, we can put print x2 dot shape to find the shape of this array, and it's going to give us the shape of it. So now we have three values here, right? So it's giving us these three values here because now we have this. Is this still somewhat into a two-dimension? It's a two-dimensional way, but it's three. So we got three brackets here. So we got two columns here. So what it's saying here is going to start. It's going to start at. It's going to have one row here, one row, the first row, and then have the second row right here, and then I have two columns. So you have one row. You got the second one is considered how big is the array is. So the array is it's a three-dimensional array, and then you have two columns long. So it's two columns long for this array. Two columns long is starting at one, the first number, and it's a three-dimensional array for that particular one. We also can do any other manipulations with it as well. We can reshape this array. So we can reshape this array. So reshaping an array, we can change this one-dimensional array into another dimensional array. So this is how you do it. So we're going to put x dot reshape, and then we're going to turn this one-dimensional array. We can turn it into a two-dimensional array. So what we have to do, we can make this two rows, four columns, because there's 8 values in this one-dimensional array. There's 8 values in here, so we know 2 times 4. So the row times the columns, 2 times 4. So the values will have to be equal. And then if you have it right here, we turned this one-dimensional array into a two-dimensional array. So we reshaped it. So we can copy that so you can see a visual of it, and we reshape that array. So now this becomes a two-dimensional array. 2D array. So since we did that, we can start to do the second one we have here. So we can print here. So now we have a two-dimensional array here. It's for x1. So we do reshape, and we gotta add the rows and the columns for here. So since we have a two-dimensional array, and we have how many values here? We have 1, 2, 3, 4, 5, 6, 7, 8. So we can do many things right here. So we altogether is 8 values here. We can make this to a one-dimensional array. We can make it one row, and then we can make it 8 columns long. And this could be, we could transform this to a one-dimensional array. But you see right there, this is now a one-dimensional array. Even though it got 2 brackets, we flatten it out to shape it into one-dimensional. And then now we have this one as well. So we got 1, 2, 3, 4, 5, 6. So now we can do many things right here with this reshape and these values. This array right here, this three-dimensional one. So we can let's put dot reshape, and then we can put, let's do 3 rows, 2 columns. It would get an error, right? And the error is going to be numpy array has no attributes of R shape because I didn't put reshape, so it's a mixed spell here. And then let's run that, and now look what we have here for reshaping it. So now that three-dimensional array is still the same thing. It's still a three-dimensional array, but you see the bracket is missing for that one. We can reshape it to other ways too. We can make it all into one row. So we'll do one row, 6 columns long. And now look what you have. You see we flatten that array as well into a one-dimensional array. So that's other ways you can do your array. You could flatten it, you could reshape it as well. You also Also, it's another function if we want to be able to add brackets to it. It's called the number dimension. It's n dimension. So we'll do this. So we'll put a comma there, and then we put NDMIN, and then we can add brackets to this array. So let's say we add 6 of it. So let's mark this out of here. Let's X this out. Number of dimensions equals 6. So when we run that, it says invalid syntax because I got a dollar sign there. No worries. So let's run that. And then you see right here, it adds 6 brackets to this one-dimensional array here. It adds 6 to it. So that function let us know how many brackets we have here. If we use, we can do this for many of the functions as well. We could do the same thing here. We could do in dimension equals, we could put 3. And then it could be the same thing for all of them. And you see right here, it added 3 to that 2-dimensional array we had. So that formula allows us to be able to add brackets. So we can erase this since we have a clear understanding of that. We have a clear understanding of that. And now it's another function. This is similar to it, but this will allow us to know this function allow us to know how many dimensions of this array. So we'll do print x dot ndim. So this function, number of dimensions, it allows us to the output allows us to know how many dimensions is the x array, the variable we created for that. You see right here, it says it's a 1-dimensional array that allows it here. So that function allows us to know how many dimensions is that array. We can print here, we can print to do the same thing, x1.ndim right there, and then we can do it for this one as well. We can do print x2.ndim. So we can do that for all of them. And then we can run and allow it. So you see this one was considered a 1-dimensional array. This one's considered a 2-dimensional array. This one's considered a 3-dimensional array. So it allows us to know the dimensions of this array. So hope everyone is following along. Let me see what's going on so I can continue. Okay, we got 18. We're up to 18 minutes. We're doing pretty good. All right, so since I don't want to go too far to the other one, we'll save it for more content. All right, so now since we got that, we can go into graphing as well. We can go into graphing. So let me cancel this code out. We can go into graphing. Oh, crap. These strings allow us to cancel out our code. So graphing, we're going to import another library called import matplotlib.pyplot as plt. And then we're going to put plt.styleUse. Style.use. This is going to be for the background of the graph, and I'm going to use dark background. So let me go back to our presentation PowerPoint right here, because we got to figure out what is Matplotlib, and this is very important too. So Matplotlib is a comprehensive library for creating static, animated, and interactive visualizations in Python. Matplotlib makes easy things easy and hard things possible. Created publication quality plots make interactive figures that can zoom, pan, and update. So Matplotlib, we're going to use the data that we have for our arrays, we're gonna be able to import it with these different graphs. So you get to see the visual. You get to see the visual of the data we're trying to create. So if we have a table of, let's say we have a table of like ice cream. So we got we got the title ice cream, and we have the different flavors of the ice cream on each column, and then the rows is the amount it calls for each of the flavors of the ice cream. So it, if you want to see the visual of the data, how many people bought this flavor, that flavor, that flavor, we're gonna use the Matplotlib to look at the visual of it. So we're gonna use that as well. So we're gonna see this in a cool graph, and we're gonna learn with the x-axis and the y-axis. You have horizontal and you got vertical. So let's go through it. Let's go back to the code. So we have that now. So now we can still implement the arrays as well. So we're gonna create x to equal to np dot array. And then we're going to make the x-axis, we're going to make a one-dimensional array. We're going to make 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And we're going to create another one-dimensional array for y. So we're going to make np.array. And then we're going to make 10, 15. We're just going to make random values, but they have to equal to the same values we have for x. So you see these random numbers. It's gonna definitely make a lot of sense once you see it. So we're doing these random numbers. Let's do 100 at the end. So we gotta make sure the values are the same for y. 1, 2, 3, 4, 5, 6, 7, 8. Let's add 2 more values. So let's make this something else. Let's make it 91. Let's make it 95. And let's make this 100. So remember, from the start, from the first value in the array to the last value in the array, that's going to be the range it's going to go to. So it's going to go in a range. It's going to start at 10. It's going to go to range 100. And this x array is going to go from the start of 1. It's going to start from 1. The range is going to start at 1. And it's going to go to range of 10. So now that's plotted. So plotting, we're going to be plotting. Plot a bar graph. So we're going to plot a bar graph. So we're going to put plt.bar, and then we're going to add for x, and y, and then we're going to add color to it. So we're going to put colors to equal to, we're going to make it red. Then we're going to do labels for it. So we'll do plt dot label for x, and then we're going to put do we have it for x? Might be x label. So we can do, let's say, I believe it's x label. So we're going to have it for the x label. So this is going to be, we'll put right here x-axis. That's going to be the side for x. And then we're going to do plt.y label, and then y-axis. So it's going to be the side for y-axis. So when you see the graph, horizontal is going to be for the x, vertical is going to be for the y. Then we're going to do plt.title, because we're going to create a title up top. Then we're going to put bar graph in the top. And plt.show is for to be able to show our graph. So when we run that, so we got an error here. So it says name red is not defined because it's not defined because it's not inside the string. All right, so now when we run this, let's run it again. All right, we got another error. Got to be color. Very meticulous in Python. All right, so we have here our bar graph. So the array, the X array that we created, you see in the bottom. So you see in a range from, well, it starts from 0, because 0, that's how they count in Python, and then you see in a range of 10. So the array that we created from 1 to 10, and then the y-axis, it starts from there. So, and then you see the y-axis from 0 to 100. So the range from 0 to 10 to 0 to the 100. Now, for reading this graph right here with this number, you see for the first one, y is at 10. It's at 10 right here. So you go closer to this, at this bar, you see in the bottom right, you see in the bottom right, you're gonna see numbers here. So this is lined up with 10 right here. So this lined up, this would be most likely 10. This would be most likely 15 here. So it's following this array right here for reading this bar graph. So we get a visual with this particular bar graph right here. So let's go to for the x-axis is going to be at 1 and 10. So you see that first bar is lined up with 1 and 10. 1 is right here, and then 10. The second one is 2 to 15. So you see 2 is lined up with 2, and then it's going to be lined up with 15. The next one would be 3. 3 is right here. 4 is going to be lined up with 25, and you see 25 is there. So we get a clear cut with this. So we get a beautiful graph right here, a bar graph right here, and we get to see the visual of our array that we created. We can create many other we could create many other graphs. So we can do a plot graph. We can just do a regular plot, and then we can make it red, and we can also add something called markers. Markers equals to, and we can add circles to it, so we can see the points. So we run this. Wait, hold up. It's not a bar graph anymore. It's a line graph. If we run this, you see we have a beautiful line graph here. So now the marker is pointing at what position it is. So you get a precise position that array is on, what axis that array is on. So it's just 1, 2, 3, 4. You see the different precisely where it's on. And we also could add another plot to it. But should we do that? Nah, we'll just leave it like that. We don't have to go too far. So this is just, we just plotting a graph right here. So just we see a beautiful graph right here that we can plot. We can plot information data to it. And you also remember I'm using the black. I'm using the black style. You can use classic. There's many others, but I just have, these are the ones I have in my head so far. Classic. And we run that, you'll see it in a classic format like this. So it's just a cool graph that you can add to it. So we're not going to go too far into graphs, just showing a brief presentation of that. And we're going to move on to pandas. So we just showed the graph that how we can manipulate it with, well, not manipulate it, how we can input this array inside this graph. So we was able to do that. So we're gonna go to the next presentation. So basically, so this is basically like, let me Hold up 1 second. So this is basically like in math, right? So his PLT like static import because there is no instantiation. Yes, PLT represents plot in a graph. So when we input our arrays or any type of data into PLT is going to plot that data in a particular graph, whether it's a plotting graph, a pie graph, or if it's a histogram. There's plenty of graphs that you do. So it's not too much math. It's enough math, like the basic understanding of math and geometry, but not too much that is going to rattle anybody. So that's what it is, to answer your question. I didn't see the comments while I was in the zone coding. So, but I'm glad to see the comments. All right, so we're gonna go to the last thing, and which is pandas. So first thing we're gonna do is we're going to import pandas as PD. Pandas is data frame. Now we into data frame. Data. So now we into data frame now. And we still gonna use Matplotlib. You're gonna see. So let's go into the pandas. So pandas is an open source Python package that is most widely used for data science. What is going on with my script? My fault. Let me read. Pandas is an open source Python package that is most widely used for data science and data analysis and machine learning tasks. It is built on top of another package named Numpy. And Numpy, that's what we explained earlier, with columns and rows. Now we're gonna input actual tables, actual data inside tables, which provides support for multi-dimensional arrays. Pandas allow importing data from various file formats such as comma separated values, which is also known as CSV files, JSON, SQL database, tables or queries, and Microsoft Excel. Data cleansing, data fill, data normalization, merges and joins, data visualization, statistical analysis, data inspection, loading, and saving data. So we're going to create a data frame. We're going to create a data frame. And then hopefully we'll have enough time to actually use the CSV file. So the first thing we're going to do, we're going to create a table, and we're going to, if anybody know about dictionaries, dictionary have keys and have values of a dictionary. So you'll have a certain topic for a dictionary. Let's say you're doing a dictionary called music, or yeah, you call it music. So the keys would be, let's say the keys be the genre of the music, which is pop, and then the values would be the artist. Well, it'll be Madonna or anybody. So we're gonna create a data frame called, let's call it, let's call it. I don't know. I don't. I want to do. I want to do sports teams. Okay, let's call it Cowboys. Dallas Cowboys. Dallas underscore Cowboys. Dallas underscore Cowboys. All right, so we can put just put top. Let's put offense. Let's do offense, and then inside the brackets we'll put we'll put names of it, back, Zeke, and Lamb. All right, so that will be offense, and then we'll do it for defense. So we create a table here. So this would be considered the columns right here, and this would be considered the rows in the columns. So we'll put defense, and then we'll put Parsons. Parsons. What's the other guy's name? I forgot the other guy's name on there. Dang, I forgot the other guy's name. I'm gonna just put Brown. I should be ashamed of myself because I'm an actual Cowboys fan, and I'll put Lawrence. And I'll put Lawrence right there. So we can actually put this inside a data frame. So we'll do is we'll put df equals pd dot data frame, and then we're going to put Dallas Cowboys there, the name of this dictionary that we created, and then we're just going to print df, and it's going to create us a table here. So it created a table here. So you see, so this would be the index of each table. So offense, we have Dak, Zeke, Lamb. Defense will have Parsons, Brown, and Lawrence. So we can input stuff in there. We can add another table. We can add it for all stars. Add stars. Yeah, we could just add the stars to the team. Dak, Parsons, and Zeke, right? So we have multiple values here. So now when we print it, we get to see that added row. So we have a table here. So you see got the table here. So 3 rows, 3 columns. So it looks like, so we got, this is really a 3-dimensional array. So we got 3 columns and 3 rows. This is just considered the name of them. So this would be considered a 3-dimensional array right here. Remember that. 3 rows, 3 columns. So can we see the amount of dimensions? So let's do print df dot ndim. You remember when we was finding out the dimensions of it? Let's see the dimensions of this array. So it says only a 2-dimensional array. 0, 1, 2, because it's based off of the index. So remember that it's based off of the index. Remember Python counts it as 0 as a number. And we also can find the shape of it. We can do print df.shape. So we can find the shape of it as well. It's 3 by 3, 3 rows, 3 columns, like I said before. So it's 3 rows, 3 columns. And we also could slice. Well, slicing and indexing is actually grabbing a value out of it. So we can do df dot, and then we can put df, and then we can just grab a let's say we want to just grab offense. So we can do offense. We just want to grab it for offense. We want to see the column just for offense. And then we get to grab the offense, Dak, Zeke, and Lamb. So we get to grab the offense. We also can grab location as well, something called lock. And we can just do a brief one before we go into CSV. We went over this. So we might just go over the data frame again, pandas data frame and axis. So a pandas data frame is a 2-dimensional data structure like a two-dimensional array or a table with rows and columns. Store data of different types, including characters, integers, floating pointing values, categorical data, and more in columns. It is similar to a spreadsheet, a SQL table, or the data. A data frame object has two axes, axis 0 and axis 1. Axis 0 represents the rows. So you see axis 0 represents the rows right here. And then you see axis 1 represents the columns. So now it's clear that the series and data frames share the same direction for axis 0, and it goes along with rows and directions. So we'll just stop it. We won't do location because we want to talk about CSV as well and then we'll just close it out there. So let's just do CSV. So like we said, CSV, comma, values. Going back here. So we talked about CSV. So it's a difference between, did we do this one? Oh, we didn't go through CSV file. So since we're here, let's go through it. So CSV stands for comma separated values, a popular way of representing a storing tabular column oriented data in a persistent storage. Pandas data frames is generally used for representing Excel-like data in memory. Files are a common file format for transferring and storing data. The ability to read, manipulate, and write data to and from CSV files using Python is a key skill to master for any data science or business analysis. The difference between CSV and XLS files format is that CSV format is plain text format in which values are separated by commas. Comma separated values, while XLS files format is an Excel sheet binary file format which holds information about all worksheets and a file including both content and formatting. So now we'll be doing the last thing. So last thing we're going to get a CSV file. I'll do a brief one. I'll find a brief one right now. So we can just go to Google and then we can just type in, put a Google here. And then we'll find a file. So I'll go to NBA basketball reference, and then we can get a CSV file here or transfer a CSV file here. So I want to grab tables. So you see the tables even for the 2021, 2022 NBA standings. You see right here, it got the columns here, it got the amount of rows here. So you see you have the table here. So let's just grab some data. So we grab data, let's see, for leaders. And for this year, for this season, and let's grab it for let's see. So we can grab it for so many different lists right here. The leaders, you see Steph Curry, his points is here. All right, so let's just grab data from Steph Curry for his career. So we'll grab it, have it for his first 10 years. So we'll grab this data here. So what we'll do is get table as CSV for Excel. And what we're going to do is we're going to just copy this data here. So you remember, it says columns is separated by columns. The values are separated by commas. So now we got that. So let me go in right here. And let's go to WordPad. You can do it on an Excel file, but I'm going to grab it on WordPad, and I'm just going to paste it here. But like they said, it's in plain text right here. And then I'm going to save it. I'm going to save it here. And then I'm going to put Curry career.csv. So I'm turning to a CSV file here. Yes. Now, since I got that there, now I can search for it. So I can put Curry career. That should have popped up here. Let me go to documents. So we can go to quick. Let's go to, all right, Curry's right here. So we can copy that path there. So let's copy that. So we should be able to copy that path. Hopefully it copies it. So the first thing we're going to do is we're going to do df1 to equal to, oh no, we're going to do data to equal to pd dot read underscore CSV. So because we want to be able to read this file here. Or it didn't copy it. All right, so it didn't copy that file. Let me check right here. Let's go to this data. Because I updated my computer, so it's a lot different now. Let's go to documents. And I want to copy this path here. Copy the path. So we copied the path of that. Now we can input this here. Usually you could put just the CSV and it'll pop up. But just in case, I just want to put the whole path here so we can make sure everything is functioning well. And then now, let's print it to see if everything is running well. So we're gonna print data, make sure it's running well, and we got the information we need, and we do. So we got Steph. So you see Steph Curry's his stats for the last 10 years. So he's able to grab that data, and now we can transform this also into a data frame. So since we got that, get that out of there, we'll put df1 equals pd dot data frame, and then we'll put that in there, and then we'll just print that. So we're going to print df1, and then now we have Steph Curry's stats for 10 years in the data frame now. So you see the columns here off. So you see for the offense. So you see the season, season, age, team. You see, not sure what that abbreviation means. League, position, and then you see his points as well. But you see his age right here as well. So you can do cool things with that. And we can see that we just want to see just only the first 5 or the first 3. We're just going to put df.head here, and that's going to give us the top 3 of those stats. So you see, just give us 3 there. So it gets us from the 2009, 2010, and then in 2011, 2012. So it'll give us the top 3 of that. And if we want to get the bottom 3, which would be later on in his career, df dot tail, and then we'll do 3. So that'll be the tail end of his career, which is pretty much currently, and we can get that data as well for the tail end of it. So you see he's 32 years old now, and then you see the points, his career points is increasing as well. So yeah, that's pretty much it. That's pretty much it that I will go over for as far as the data. We'll go over that, and we can stop it here. Hope everyone enjoyed the presentation, and this presentation is very useful, and you can use it and you could practice it on your own. It's beginning friendly. So I hope everyone enjoyed it. So please follow me on my IG at Trade Digital 89, and also subscribe to this channel because I'm going to make sure I do more videos like this. So I hope everyone enjoyed this, and that's it for this episode. This is the Trade Digital episode, and follow me and have a good day.